Okay, so let's look at this problem. Uh, Problem 26. Viewers of Star Trek have heard of the antimatter drive on Starship Enterprise. One possibility of such a futuristic energy source is to store antimatter charged particles in a vacuum chamber circulating in a magnetic field and then extract them as needed. Antimatter annihilates normal matter, producing pure energy. What strength magnetic field is needed to hold antiprotons moving at 5 times 10 to the power 7 meters per second in a circular path 2 meters in radius? Antiprotons have the same mass as protons but negative charge. Is this field strength obtainable with today's technology, or is it a futuristic possibility? Okay, so what is happening is so let's say the magnetic field is like so, and antiprotons are going in a circle. They're negatively charged particles, and let me figure out the direction in which they need to be moving, and the radius of the circle is 2 meters. Okay, 2 meter radius. Okay, now let me just figure out the direction of the velocity. If it moved in this direction, the force, what we need is a centripetal force toward the center. So at this point, if it moved in this direction, V cross B, the force on the screw would be inward. So since it's a negative charge, okay, so you guys will have to figure this out, but the velocity of the electron is in this direction. The velocity of the proton is in this direction. Okay, so now here's a top view of the situation. Okay, so the field is coming out. This is the magnetic field, and so the proton, again, top view, if it moves in this direction, coming out, yep, okay, so that's not what I wanted. Here's what I want. Here's the direction of the velocity. So the magnetic force is providing the centripetal force. Okay, so magnetic forces, since Q, V, B, the magnetic forces Q, V cross B, and since V and B are perpendicular to each other, the magnitude of the magnetic force is QVB, and the centripetal force is mass V squared by R. Okay, so what are we solving for? What is the strength of the magnetic field? So what is the strength of the magnetic field we need for the proton to go in that 2 meter circle? So M, one of the V's cancels, so one of this V cancels. So we have MV, B is equal to MV Q by R. All right, let's add a page. Okay, and now let's calculate the magnitude of this magnetic field is M V B, oops, what happened here? QR. Okay, the mass of the proton is 1.6 times 10 to the minus 27 kgs. I believe the velocity of the proton is 5 times 10 to the 7 meters per second. The charge of the proton is 1.6 times 10 minus 19 coulombs, and the radius is 2 meters. Okay, so the magnetic field needed is, all right, let's take care of powers of 10. 27, that's minus 8. This is minus 8, and times 10 to the 7, that's minus 1. So this is the 1.6 cancels, so it's the magnetic field needed is 0.5 over 2 equal to 0.25 Tesla. Oh yeah, this is easily achievable. The MRI machines, you just need a superconducting magnet, so this is definitely a possibility. Okay. So part B says, is this field strength obtainable with today's technologies? Okay, so this is possible today. Okay. All right, that finishes this problem. So let's stop this recording.